This course will guide you through Michio Kaku's profound ideas on the universe's origins, covering everything from string theory to the potential existence of a multiverse, a reality where our own cosmos is just one of many. For Kaku, understanding where the universe came from is not merely a scientific puzzle. It represents the very key to unlocking the fundamental nature of reality and our own significance within it. In the realm of science communication, Michio Kaku is a prominent figure who has devoted his life to unraveling cosmic secrets, acting as an essential link between scientific complexity and public curiosity. His remarkable talent for making intricate subjects understandable has motivated millions to gaze at the stars and contemplate what exists beyond our familiar world. The personal journey of Michio Kaku himself is quite remarkable, marked by an insatiable hunger for science and physics from a very young age. You can picture a young man who, rather than engaging with common toys, dedicated his time to constructing model rockets and dreaming of interstellar journeys. This early passion propelled him to become one of the most significant physicists of our era. His motivation for sharing this vast knowledge stems from a simple yet powerful wish for everyone to have the opportunity to peer through the same cosmic window and witness the universe as he does. Any exploration into the universe's beginnings must address the Big Bang Theory, a transformative idea suggesting that everything we comprehend originated from a single, colossal explosion. To truly grasp this, think of it like blowing up a balloon. It starts small and expands as you fill it with air. This is an analogy for our universe, which began as a point of incredible density and heat, and has been expanding continuously since that moment. This simple visualization helps us understand the process by which our reality emerged. The universe's expansion is more than a simple fact. It fundamentally changes how we perceive the cosmos. When you observe the stars in the night sky, you are actually looking into the past, as the light you see from those distant stars has journeyed for millions of years to reach your eyes. Yet, what if I were to tell you that this expansion is ongoing? With every passing second, galaxies are moving farther apart, driven by some immense cosmic force, which naturally leads us to question the ultimate destination of it all. From this concept of expansion emerges the captivating theory of cosmic inflation, which proposes that in the moments immediately following the Big Bang, the cosmos experienced an almost instantaneous and exponential growth spurt. Imagine the universe doubling its size repeatedly in the blink of an eye. While this period of rapid expansion helps account for the large-scale uniformity we observe today, it also opens up new inquiries, chief among them being what could have possibly existed before this inflationary event took place. Our investigation into these mysteries leads us to the baffling ideas of dark matter and dark energy. Although these unseen components constitute the majority of our universe, we cannot directly perceive or interact with them. Their presence is much like the air you breathe, essential and all around us, yet often unnoticed. We confirm their existence by observing their profound gravitational influence on the behavior of galaxies and the path of light traveling through space. The principle of symmetry in physics is another vital element in grasping the universe's origin, as the elegance and order found in nature are a reflection of the fundamental laws governing the cosmos. The importance of this symmetry can be compared to a jigsaw puzzle. When every piece fits perfectly into its designated spot, a complete and coherent picture is formed. In much the same way, the laws of physics ensure that every particle and every force has a specific role within the grand design of the universe. As our guide, Michio Kaku also introduces us to the complexities of string theory, which offers a potential framework for unifying nature's fundamental forces. This theory proposes that at the most fundamental level, particles are not points, but are instead minuscule, vibrating strands of energy. The specific manner in which these strings vibrate is thought to determine the properties of all matter, suggesting that everything in the cosmos might be interconnected in a way we never before conceived. The notion of the multiverse presents another fascinating and mind-bending area of discussion, prompting us to ask if our own cosmos is merely one among an infinite number of others. The idea of countless parallel universes, each potentially governed by its own unique set of physical laws and realities, is both astonishing and deeply thought-provoking. If life could emerge in our universe, it compels you to wonder how many other forms of existence might flourish across this vast cosmic network. Our quest for understanding is also deeply intertwined with the paradox of time itself, a concept most of us think of as a linear progression from past to future. However, Kaku encourages you to envision time not as a straight arrow, but as a malleable curved dimension that can be bent and warped. Adopting this perspective could radically alter how you perceive the past, present, and future, forcing you to question whether there is any true beginning or end. Ultimately, we are left to consider how the Big Bang didn't just give rise to the universe, but to time itself, a concept that can be challenging to fully comprehend. But what if I were to tell you that our entire concept of time was born in that single, explosive instant? Such a realization forces us to confront profound questions about our own existence and our ongoing search for purpose within this cosmic timeline. Throughout this exploration, you have examined the physical laws that enabled the universe to take shape. In his distinctive way, Kaku prompts us to recognize that these principles are not just abstract equations, but are the very rules that dictate our daily existence. This brings up deeper questions about whether science and spirituality can find common ground, and if there might be an underlying purpose to the sheer immensity of the cosmos. As we get ready to delve even further into these subjects, the path forward is unmistakable. Our exploration must continue, because the cosmos is an immense sea of puzzles and marvels. Each new discovery edges us closer to understanding our identity and our origins. In this expansive field of science, Michio Kaku shines as a guiding light of knowledge and inquiry, reminding us that curiosity is the essential first step on a journey that has only just begun. So, who exactly is this theoretical physicist and popularizer of science? To truly grasp his influence, you have to look into his life and career. He was born in 1947 in San Jose, California, and from his youth, Kaku displayed a relentless fascination with the universe. This early inquisitiveness famously drove him to construct a particle accelerator in his family's garage, an ambitious undertaking that clearly hinted at his destiny in physics. His academic journey was just as remarkable. Kaku attended Harvard University, graduating with a bachelor's degree in physics, before continuing on to the University of California, Berkeley, for his doctorate. It was there that he delved deep into the realm of theoretical physics, choosing to specialize in string theory, which is a framework attempting to describe the fundamental workings of the universe's elementary particles. However, Kaku is more than just a brilliant scientist. He has mastered the art of communication, translating scientific intricacies for a wider public. Using books, lectures, and TV shows, he has a talent for making challenging subjects both understandable and captivating. You might ask why communicating science is so vital. Kaku is convinced that science isn't meant to be confined to labs and academic halls. He sees it as our common human inheritance, and by sharing this knowledge, he hopes to encourage future generations to embrace curiosity and challenge their understanding of the world. In our current era, where we are bombarded with information, the skill of separating fact from falsehood is more crucial than ever, and Kaku's efforts are essential in promoting this kind of critical thought. Among his most fascinating contributions is his work on string theory, which proposes a breathtaking new perspective on the cosmos, that fundamental particles are not tiny dots, but minuscule, vibrating filaments of energy. Kaku has investigated how this concept might unite all of nature's forces and potentially resolve some of the most profound mysteries surrounding the universe's creation. So, what is it that makes this theory so compelling? Fundamentally, it hints that our reality possesses a complexity and elegance far beyond what you might envision. Outside of his academic pursuits, Michio Kaku tirelessly champions science in popular media, where his magnetic personality and knack for simplifying difficult ideas have established him as a vital link between the scientific community and the public. He has introduced the universe's deepest puzzles into millions of homes through his television programs and documentaries, which leads you to ask how he manages to make science so enthralling. The answer lies in his infectious passion for knowledge and a narrative skill that animates even the most theoretical subjects. Kaku frequently engages with contemporary scientific issues, from artificial intelligence to the chances of discovering life on other worlds. His perspective isn't limited to physics. He also explores the ethical dimensions and societal impacts of new scientific discoveries. This serves as a reminder that science isn't an isolated discipline. It's profoundly intertwined with the human condition and our collective goals. It leads you to ponder what part science will ultimately play in shaping our destiny, a question whose answer might be as intricate as the cosmos. An additional dimension to his work is the conversation he fosters between science and spirituality. Kaku has investigated how breakthroughs in science can shape our perceptions of the divine and the metaphysical. This layered perspective showcases his ambition to blend various ways of knowing. In a world that often pits science against religion, he proposes a framework where they can not only exist together, but also mutually enhance one another. Over the course of his career, Michio Kaku has authored numerous books that have garnered praise from both reviewers and the general public, with titles like Physics of the Future and The Universe in a Nutshell, exemplifying his talent for linking profound concepts to ordinary experience. In these books, Kaku encourages all of us to envision a future where scientific and technological progress improves our existence in ways we can currently only dream of. The kind of future that truly lies ahead is ultimately up to us, defined by the choices you and I make in our quest to investigate and comprehend our world. Ultimately, Michio Kaku represents more than just the power of human curiosity and intellect. He serves as a crucial connection between the scientific realm and the public. His gift for communicating difficult ideas in a clear way has motivated countless people to gaze at the night sky and contemplate their own position within the cosmos. The way he frames it, science is less a formal discipline and more a collective journey into uncharted territory. While you can't know what breakthroughs lie ahead, one thing is certain. Our search for knowledge will persist, and Kaku's passionate commitment will continue to illuminate our path. The Big Bang Theory stands as a foundational pillar of contemporary cosmology. For many of us, the term Big Bang conjures images of a spectacular cosmic explosion, but the event wasn't an explosion in the way you might think. It was, instead, the very instant the universe initiated its expansion from a state of unimaginable heat and density. So, you might ask, how can we be sure of this? And what proof supports this entire framework? A primary piece of evidence emerges from studying the light from faraway galaxies. When you gaze into the cosmos, you are not just seeing stars, but also looking back in time, as the light from these galaxies has taken billions of years to arrive. The revelation from this observation is staggering. Nearly all galaxies are receding from us. This observation can only mean that the fabric of the universe itself is stretching. If you rewind this cosmic expansion, it logically leads to a conclusion that everything must have once been compressed into a single, infinitesimal point. The principle known as Hubble's law famously describes how a galaxy's distance from us is directly related to the speed at which it is moving away. You can visualize this by picturing dots drawn on a balloon. As you inflate it, all the dots move farther apart from one another, which is a perfect analogy for how galaxies are separating as space itself expands. This leads to profound questions about what preceded that first moment, and what, if anything, existed before the Big Bang. These are mysteries that continue to captivate us, prompting scientists to develop multiple hypotheses about the universe's pre-Big Bang condition. Some theories postulate a primordial state of pure energy, while others envision a universe caught in endless cycles of expansion and collapse. What we can be certain of, however, is that the very laws of physics as you and I know them began to crystallize at the moment of the Big Bang. You must try to grasp that in a single, infinitesimal moment, the cosmos not only burst into being but also commenced a period of incredible, rapid growth from a seething, primordial soup of energy and particles. This raises the question of how the elements familiar to us today, like hydrogen and helium, could have possibly emerged in the first few minutes of cosmic history. Physicists theorize this happened through nucleosynthesis, the process that forged the very first atomic nuclei. As the universe's expansion continued and its temperature dropped, atoms could finally form, eventually clumping together under gravity to give birth to the first stars and galaxies. Remarkably, the light you see from distant stars is a direct echo from those initial cosmic moments, which means that when you gaze at the night sky, you are looking at the history of our universe written in photons. The Big Bang theory finds further powerful support in the cosmic microwave background, which is the residual heat signature left over from that initial burst. This faint radiation serves as a definitive fingerprint of that first instant, carrying invaluable data about the temperature and density of the early universe. Imagine an extinguished campfire that still radiates a gentle warmth long after the flames are gone. This cosmic radiation is precisely that, the lingering heat of the Big Bang. By studying this warmth, we gain clues about the universe in its infancy. Over the decades, the Big Bang theory has been subjected to innumerable tests and observations, and with every new piece of evidence, our confidence in it has only grown stronger. But does this accumulated evidence mean the theory is entirely complete? The answer is a definitive no, as numerous questions remain unresolved, compelling us to push our explorations even further. For instance, what is the true nature of dark matter and dark energy, and what is their relationship to the Big Bang? The theory, therefore, is more than just an origin story. It is the fundamental framework for comprehending the entire evolution of the cosmos. This framework inevitably leads you to confront profound philosophical questions about our own place within this grand cosmic scheme. What does it truly signify to be part of a universe that exploded into existence billions of years ago? The implications are staggering, inviting you to contemplate the very essence of existence itself. The Big Bang is a portal to our distant past, a call to venture into the unknown, and a powerful reminder that we are surrounded by mysteries waiting to be solved. As we persist in our quest for knowledge, we inch ever closer to understanding, not just how everything began, but also where we are ultimately headed in this immense cosmos. The pursuit of our universal origins is a perpetual journey, constantly presenting new questions and unforeseen possibilities for us to explore. The very expansion of the universe is an enthralling reality that forces you to reevaluate your position in the grand order of things. How can it be that every object we can observe is moving away from us? This profound mystery originates with the pioneering work of astronomer Edwin Hubble in the 20th century. He was the one who revealed that the cosmos is filled with countless galaxies, and, more astonishingly, that they are all receding from our vantage point at incredible speeds. This observation logically prompts an intriguing follow-up question. If all the galaxies are currently moving apart, doesn't that imply they must have once been consolidated together? The answer to that question lies at the very core of the Big Bang theory, which proposes that the universe originated from an incredibly hot and dense singularity, approximately 13.8 billion years ago. From that point onward, it has been in a state of continuous expansion, much like the surface of a balloon that stretches outward as you fill it with air. But the driving force behind this relentless expansion remains a perplexing and poorly understood cosmic mystery. When you delve into this topic, you discover that the universe's expansion is not simply about objects moving apart. It's a revelation about the fundamental fabric of reality itself. Each galaxy you can see in the night sky acts as a brilliant beacon, narrating a story about the distant past. The ever-increasing distances between them confirm that the universe is not a static stage, but a dynamic, perpetually transforming arena. So, how can we be sure these cosmic distances are genuinely increasing? Astronomers employ an instrument known as a spectroscope to analyze the light emanating from distant galaxies. Upon examining this light, they observe that its wavelengths are stretched toward the red end of the spectrum, a phenomenon called redshift. This effect is analogous to how the pitch of a siren seems to drop as it speeds away from you, providing clear evidence that the universe is indeed expanding. While we can confidently assert that the universe is expanding, this fact leads to a much deeper consideration of its ultimate fate. As space stretches, its overall temperature steadily drops, which raises new and fascinating questions. Will the cosmos eventually cool into a perpetually frozen state, or will it somehow reach a new equilibrium far in the future? This expansion influences not just galaxies, but all the matter and energy that constitute reality. In fact, we now believe this expansion is propelled by an enigmatic force called dark energy, which is thought to make up roughly 70% of the total content of the universe. Dark energy stands as one of the greatest puzzles in modern cosmology, leaving us to wonder what it truly is and why it appears to be making the expansion of the universe accelerate over time. The concept of an expanding cosmos also forces you to ponder the nature of time itself. As the universe grows, time seems to play an integral role, but the exact connection between cosmic expansion and the flow of time remains elusive. It is as if space and time are inextricably woven together into a single cosmic fabric that is continuously unfurling, causing the events within it to evolve and change as it stretches. Finally, the expansion of the universe brings you face to face with the dizzying concepts of the finite and the infinite. Could it be that the universe possesses an infinite volume, but is finite in age? Or is it possible that there is a boundary to this expansion, a point at which it might halt, and perhaps even begin to reverse, pulling everything back together in a cosmic collapse? The notion that our universe might one day collapse back into itself is a prospect that fuels both scientific speculation and deep philosophical reflection. It forces you to confront a fundamental question. What is our purpose within this immense cosmic theater? While the ongoing expansion of the universe certainly highlights our own insignificance against the vastness of space, it simultaneously invites you to feel a sense of wonder at being a participant in this magnificent spectacle. This inherent human curiosity is precisely what has compelled countless scientists to investigate the full meaning of cosmic expansion. You have to wonder, are we the only beings in the universe posing these kinds of questions? The drive to find answers compels us to gaze toward the heavens, to trace the paths of stars, and to imagine what lies beyond the confines of our world. With every new discovery and each technological leap, our comprehension of the universe's mechanics grows clearer. We employ an array of tools in this quest, including space missions, advanced telescopes, and powerful computer simulations. What makes this pursuit so thrilling, however, is that each answer we uncover invariably gives birth to a host of new questions, pushing us toward new horizons of exploration. Ultimately, the expansion of the universe represents more than just a physical event. It stands as a testament to our own unending search for knowledge. It forms a bridge connecting us to all past generations who looked up at the same night sky and contemplated their own position in the cosmos. This expansion is an endless voyage, a continuously unfolding narrative that beckons you to never stop investigating and never cease questioning. Now, try to visualize the very first moments of the universe's birth, when all that you know was compressed into a point of unimaginable density and heat. This idea, which we call cosmic inflation, serves as a cornerstone for our understanding of how everything began. But what is the true meaning of cosmic inflation? And why does it hold such a critical place in modern cosmology? Imagine the universe is like a balloon that you are blowing up. As you inflate it, the surface stretches out at an incredible rate, causing points that were once side by side to become separated by vast distances. Cosmic inflation mirrors this process, but on a scale involving the very fabric of space and time. This expansion is not merely about creating distance. It's about how galaxies and all cosmic structures took shape over billions of years. To grasp the concept of cosmic inflation, you must journey back to the very dawn of time. In the instant following the Big Bang, the universe was a place of such extreme heat and density that our known laws of physics were not yet applicable. It is within this primordial state that a period of exponential expansion is thought to have occurred in an infinitesimal fraction of a second. The precise cause of this event is still a subject of intense study, but scientists theorize that a unique form of energy, often called vacuum energy, might have been the driving force behind this phenomenon. Cosmic inflation does more than just account for the universe's expansion. It also elegantly addresses several perplexing issues that the original Big Bang model could not explain on its own. For instance, how did the universe achieve such a remarkable degree of uniformity and homogeneity on the largest scales? Without the theory of inflation, explaining how widely separated regions of the cosmos share similar characteristics would be impossible. Inflation suggests that infinitesimally small fluctuations in the density of the primordial universe were stretched and magnified, eventually growing into the structures you see today: galaxies, clusters, and superclusters. Yet, the idea of cosmic inflation also introduces some truly fascinating new questions for you to consider. If the universe expanded with such astonishing speed, what could have possibly existed before that moment? Was there something present at that initial point, or did everything we observe truly spring forth from a state of absolute nothingness? Some scientific models propose that our universe might be just one part of an eternal cycle of expansion and contraction. Others entertain the possibility that multiple universes exist, each having undergone its own unique inflationary history. It is truly staggering to think that in such a fleeting instant, the fundamental laws that dictate the workings of our reality were permanently set in place. The concept of a multiverse is deeply intertwined with inflation, suggesting that the universe you know could be just a tiny fragment of a far grander and more intricate cosmos. But how could we ever verify a theory as abstract as cosmic inflation? Scientists are actively searching for evidence through astronomical observations and sophisticated experiments. One of the most promising avenues of research involves the study of gravitational waves, which could carry faint signatures from that very early epoch of the universe. The possibility that an echo of inflation is still reverberating throughout the cosmos is a genuinely exciting prospect. Contemplating cosmic inflation also encourages you to reflect on the very nature of time itself. If time truly began with the Big Bang, what does that imply about your own perception of it? In this framework, inflation introduces yet another layer of complexity to our understanding of the profound connection between space and time. Exploring this concept is not just a journey into the distant past, but an invitation to ponder your own significance in the universe. If the cosmos is expanding and has experienced phases of rapid inflation, what does that reveal about its ultimate destiny? Theories of eternal expansion propose that the universe might just continue to grow indefinitely. In the end, cosmic inflation is a powerful idea that not only helps us understand the origins of everything, but also forces you to confront profound questions about the very essence of existence. As our exploration and discovery continue, every new piece of this cosmic puzzle brings us a step closer to solving the great mysteries of our universe. Imagine that you are, in fact, part of a story much larger and more complex than you could ever have conceived. Cosmic inflation is merely one chapter in this immense saga, but it's one that empowers you to dream and to wonder about your place in this boundless cosmos. As we journey forward, it's our inherent curiosity and quest for knowledge that compels us to explore, because the cosmos, in the end, still has countless surprises in store for us. Have you ever stopped to consider what our universe is fundamentally made of? While most of you are acquainted with the ordinary matter that constitutes everything from stars and planets to our own bodies, there are two other components lurking in the cosmic shadows: dark matter and dark energy. What are these mysterious substances, and why are they so essential to our comprehension of the universe? Dark matter presents a captivating puzzle. Picture yourself in a completely dark room, trying to find something you've misplaced. You can't see the object directly, but you sense its existence by how it interacts with its surroundings. Perhaps you bump into other items it has moved, or you notice how light bends around its location. In much the same way, we can't observe dark matter, yet its influence is evident in the behavior of entire galaxies, and it's thought to account for about 25% of the universe's total mass energy content. To grasp how something so prevalent can remain so elusive, let's examine the rotation of galaxies. Think about watching a spinning carousel. If you only paid attention to the horses without considering the powerful motor hidden beneath, you would never understand its incredible speed. Dark matter functions as this concealed engine, supplying the extra gravity required to bind galaxies together. Without its presence, the stars on the galactic fringes would behave very differently, and our entire model of the cosmos would fall apart. Dark energy, on the other hand, is an even more profound mystery, as this force is driving the accelerated expansion of the universe. Imagine you are blowing up a balloon. Initially, it inflates at a steady rate, but then you feel it begin to expand faster and faster. Dark energy acts like the very breath, pushing against the balloon's inner surface, causing the cosmic expansion not just to persist, but to speed up over time. But what could this dark energy actually be? Scientists have put forth a number of hypotheses to explain it. One leading idea suggests it is an intrinsic property of space itself, a kind of vacuum energy that generates a negative, repulsive pressure. Other theories propose it might be a new type of energy field that we have yet to comprehend. The question that hangs over all of this research is whether we will ever manage to directly observe and understand this force that constitutes the majority of our universe. Fundamentally, the interplay between dark matter and dark energy is crucial. You could envision a vast cosmic chess match where galaxies are the pieces on the board. In this game, dark matter dictates the rules that govern how the pieces can move, while dark energy is the unseen player who determines when and how rapidly the board itself will expand. Acting in concert, these two invisible forces are actively sculpting the ultimate destiny of our universe. As the scientific community delves deeper into these cosmic unknowns, each step forward raises even more questions. What happens if we find out that dark matter is something entirely different from what we currently believe? What if dark energy possesses properties even more bizarre than we now imagine? Any new discovery has the potential to fundamentally transform our entire understanding of the cosmos. Our innate human curiosity is what fuels the ongoing effort to find answers to these profound mysteries. Current experiments, ranging from powerful telescopes that analyze light from distant galaxies to sophisticated particle accelerators designed to detect dark matter, represent the front lines of this scientific quest. With every technological advancement, we inch closer to unveiling these cosmic secrets. But you have to wonder what will happen when we can finally perceive the invisible. The implications of deciphering dark matter and dark energy are truly monumental. A full understanding could reshape our concepts of space, time, and perhaps even the nature of our own existence. If we succeed in unraveling the true nature of these forces, we may also get a glimpse into the far future of our universe. Are we destined for an unending expansion into cold emptiness? Or is a final collapse an eventual possibility? The story of dark matter and dark energy extends beyond a mere scientific inquiry. It poses a philosophical challenge. It compels us to reevaluate our definition of reality and our own position within the cosmos. What is the significance of being human in a universe where the vast majority of what exists remains hidden from our senses? These profound questions invite us on a deep journey into the heart of our own existence. In his own work to comprehend the universe, physicist Michio Kaku has also tackled these subjects. He views the study of dark matter and dark energy as an indispensable step in the search for a unified theory that could explain all the fundamental forces of nature. Kaku encourages us to envision a future where these cosmic mysteries are no longer shrouded in darkness, but are instead illuminated by the light of human knowledge and curiosity. Ultimately, dark matter and dark energy are far more than abstract ideas. They represent gateways into a new realm of possibilities. As our comprehension advances, each answer we find only seems to generate new questions. And this cycle is the very essence of scientific progress. In this immense cosmos, where everything we can see is just a tiny fraction of the whole, the pursuit of knowledge pushes onward, propelled by our insatiable curiosity. What incredible discoveries await us in the future? Only time will tell, and we will be here, poised to explore them. Symmetry is an incredibly compelling concept that lies at the very core of physics. Have you ever paused to ask why the universe operates the way it does? This principle of symmetry provides us with some answers while simultaneously presenting us with new and fascinating questions. We can observe symmetry all around us in the natural world, from the elegant form of a flower to the intricate structure of a crystal. But what does any of this have to do with the universe's origins? First, you should understand that in the realm of physics, symmetry is not just a matter of aesthetics. It is an exceptionally powerful analytical tool that scientists employ to decode the fundamental laws that govern our universe. Think of the laws of physics as a complex card game. Symmetry represents the unchangeable rules that define how the game can be played. If these rules didn't exist, it would be a game of pure chaos where nothing is predictable. Symmetry also serves a foundational purpose in the conservation of certain physical quantities. For instance, the symmetries associated with time and energy directly lead to the principle that the total amount of energy within any closed system must always remain constant. Consider the balance of a scale. For stability to be maintained, any weight added to one side requires an equal compensation on the other. Nature relies on a similar principle of symmetry to preserve its fundamental properties. Without it, the universe would descend into utter chaos. Have you ever stopped to consider the very reason fundamental particles like electrons and quarks even exist? The explanation is rooted in symmetry. In the world of physics, this concept of particle symmetry dictates that every type of particle is accompanied by a partner with related characteristics, revealing a deep, underlying pattern that organizes all particles into distinct families. Without this foundational symmetry, scientists would find it nearly impossible to predict the behavior of particles under various conditions. As you explore the role of symmetry in physics more deeply, you discover that it comes in several forms. Among the most compelling is gauge symmetry, which serves as the bedrock for the unified field theory. This ambitious theory aims to show how all the universe's fundamental forces, including gravity, electromagnetism, and the nuclear forces, are intrinsically linked. You can visualize gauge symmetry as an invisible web that connects these forces, orchestrating their interactions with one another and weaving the fabric of reality. Another vital concept, which may initially seem paradoxical, is that of symmetry breaking. There are moments when the universe acts in unforeseen ways, and these perfect symmetries can be shattered. Picture a flawlessly balanced puzzle that suddenly loses a piece. Its original symmetry is gone. For physicists, such an event is profoundly significant, as it can signal the birth of new particles and forces, which in turn helps us comprehend phenomena like the origin of mass. This very breaking of symmetry is essential for explaining why certain particles possess mass while others are massless. Symmetry also compels you to contemplate the fundamental nature of space and time themselves. What if time were perfectly symmetric? Theoretically, that would imply you could travel backward and forward in time with the same freedom you move through space. Yet, our reality is defined by time's unwavering forward direction. This temporal asymmetry suggests there is an inherent quality to our universe that dictates the specific sequence in which all events must unfold, preventing us from reversing their course. So, what does symmetry tell you about the birth of the cosmos? In the very first moments after the Big Bang, the universe existed in a state of extreme, almost perfect symmetry. But as it began to expand and cool, these pristine symmetries started to fracture, giving rise to the incredible variety of particles and forces that we are familiar with today. This entire process can be pictured as an elegant cosmic performance, where initial simplicities dissolve to make way for the complexity and diversity of the universe. Symmetry is also a crucial element in the ongoing quest for a unified theory capable of merging all of nature's forces into a single framework. Numerous scientists, Michio Kaku among them, are convinced that a master theory exists that can explain everything from the pull of gravity to the strange rules of quantum mechanics. Symmetry represents the most promising path toward this grand unification, much like searching for the master blueprint behind an intricate tapestry where every single thread has its designated place and purpose. Furthermore, you can find symmetry not just in the abstract realm of physics, but all around you in the natural world. You can witness it in biology, from the structured growth of plants to the elegant forms of animals. Such recurring patterns suggest the existence of universal principles that govern both the vastness of the cosmos and the intricacies of life on our planet. This profound link between physics and biology leads you to consider that symmetry may be a truly fundamental attribute of all reality. When you reflect on this, you might wonder what it means for you, as a human, to inhabit a universe governed by these principles. Symmetry does more than just organize the cosmos. It provides us with an innate sense of beauty and order. It serves as a reminder that, in spite of all our individual differences and apparent inequalities, we are all connected by a deep, underlying pattern. Ultimately, symmetry is a foundational concept that allows us to decode the universe's greatest mysteries, demonstrating that order exists within chaos, and that nature operates according to rules that are ultimately understandable, however complex they may seem. String theory presents a remarkable vision for unifying all the forces of nature into one cohesive picture. But what does that truly involve? To grasp this idea, it helps if you imagine the universe as a tremendous ocean, with each current and wave symbolizing a fundamental force. Within this cosmic ocean, string theory functions like a grand conductor, harmonizing these distinct waves into a unified symphony of existence. At its very core, the theory proposes that the subatomic particles you typically picture as simple points are, in fact, minuscule vibrating strings, far too small to be observed even with our most advanced instruments. So, how does this notion alter your perception of the universe? It turns out that each unique vibration of these strings corresponds to a different type of particle, meaning the specific way they oscillate determines the very nature of the matter you see all around you. It's an astounding thought that the heart of all matter is composed of vibrating melodies that collectively create the grand symphony of the cosmos. String theory aims to describe not only the particles themselves, but also the forces that bind them together. For example, the force of gravity that anchors you to the earth can also be explained as a manifestation of these strings. To better visualize this, think of a musical instrument. The vibration of a string produces sound waves that travel through the air. In a similar fashion, the vibrations of these fundamental strings generate waves that we perceive as the forces interacting throughout the universe. This direct link between vibration and force is a revolutionary idea that could completely reshape our understanding of physics. Fascinating questions naturally emerge from this framework. If all things are made of vibrating strings, then what does that make a black hole? Once considered the ultimate cosmic enigmas, black holes are viewed in a new light through string theory. It suggests that these mysterious objects might actually be a special configuration of vibrating strings, implying that even the most profound secrets of the universe are part of this beautiful, hidden harmony. Perhaps one of the most captivating features of string theory is its proposal that our reality contains additional, unseen dimensions. This idea suggests a cosmos far more complex and layered than the one you perceive every day. Although we experience a world of 3 spatial dimensions and 1 of time, this theory proposes the existence of additional dimensions that are hidden from our perception. To understand why extra dimensions might exist, consider a sheet of paper crumpled into a ball. From far away, it seems like a 2-dimensional object, but as you get closer, you realize it possesses a 3rd dimension. The additional dimensions in string theory could be much the same, unseen, yet essential to the very fabric of our universe. This raises a fascinating question. If these strings are vibrating within a space that has more dimensions, could it mean that multiple realities exist simultaneously? Imagine each distinct vibration of a string in one of these extra dimensions, giving birth to an entirely separate universe. This is how string theory becomes deeply connected with the multiverse concept, hinting that our reality is just one piece of an immense cosmic tapestry, woven from countless alternative worlds. String theory also makes a bold attempt to resolve some of the most persistent problems that have perplexed physicists for generations. For instance, the effort to unify quantum mechanics with general relativity has long been a monumental challenge. String theory presents a potential pathway forward by weaving both of these foundational theories into a single, more comprehensive framework. It's truly incredible to consider that we may be on the brink of solving one of the most profound mysteries in all of physics. Yet, string theory faces significant criticism, as many scientists raise doubts about its capacity for empirical validation. In a discipline where hard evidence is paramount, you have to ask how we can embrace a theory that seems beyond our ability to observe, prompting a deeper look into the very nature of scientific inquiry. The profound appeal of string theory is rooted in its sheer mathematical elegance, with many physicists captivated by the poetic quality of its equations, which appear to move in perfect concert. This leads to a critical question. How much of this perceived beauty reflects an underlying truth versus how much is simply an attractive construct of mathematics? Science often walks a fine line between artistry and logic, and string theory stands as a perfect illustration of this dynamic. When applied to the universe's creation, string theory proposes that the initial conditions of the Big Bang might have been dictated by these fundamental vibrating strings. Such a model could provide answers to our most basic questions about how and why the cosmos came to be. If the vibrations of strings were indeed the cosmic spark that set everything in motion, it suggests that every one of us shares a connection to that original primordial resonance. As we explore string theory more deeply, the role of consciousness inevitably enters the conversation, raising profound questions. Is it possible that we are, in some fundamental way, a direct expression of these cosmic vibrations? The notion that our very being is woven into the structure of reality itself opens up a fascinating dialogue about the true nature of life and awareness. The quest for a unified theory through strings is far more than an intellectual puzzle. It's a journey to discover our own place within the cosmos. Should we succeed in decoding the secrets of these strings, we could move a significant step closer to understanding the true origins of everything. On this quest, science and philosophy become intertwined, pushing our thoughts from the purely physical into the realm of the metaphysical. In the end, string theory is not just a scientific model, but a powerful invitation to be curious. It beckons you to venture into the unknown, to challenge what you believe to be true, and to stand in awe of the universe's complexity. With every new question and each discovery on this path, we inch closer to grasping the essence of existence, all while the cosmic symphony of vibrating strings plays on around us. Have you ever stopped to consider that our universe might not be the only one in existence? This concept of a multiverse has captivated the minds of both scientists and philosophers. Picture an endless ocean of separate universes, each governed by its own unique laws of physics and filled with its own realities. This idea, which may at first seem like pure fantasy, is a subject that the esteemed theoretical physicist Michio Kaku explores with great passion, urging you to think beyond our familiar cosmic horizon. The multiverse concept actually emerges from interpretations of core scientific theories like quantum mechanics and cosmic inflation. Quantum mechanics, for example, posits that subatomic particles exist in a cloud of probabilities until they are measured. This has led some physicists to theorize that with every observation, the universe splits into countless branches, creating alternate realities where every possible outcome is realized. In one of these universes, you may have followed a different life path entirely. Cosmic inflation, on the other hand, offers an explanation for how our universe underwent a period of explosive growth just moments after the Big Bang. This rapid expansion may not only have created the cosmos we inhabit, but could have also spawned countless other bubble universes within a greater multiverse. Each of these bubbles could possess its own fundamental laws and dimensions, making you wonder what a universe with stronger gravity or a faster passage of time might be like. Michio Kaku also emphasizes how crucial string theory is to the multiverse discussion. This theory reimagines subatomic particles as tiny strings vibrating in higher dimensions. Following this logic, the various ways these strings can vibrate could each correspond to a different universe with its own set of physical characteristics. In this view, the multiverse becomes an almost inevitable consequence, providing a natural stage for an infinite variety of cosmic possibilities to unfold. This, however, brings us to a compelling and difficult question. How could we ever prove that these parallel universes are real? The answer is far from straightforward. Science typically relies on observation and experimentation to make progress. But when it comes to the multiverse, physicists are confronted with an extraordinary and unique challenge. We might never be able to witness other universes directly if they are entirely separate from our own. However, some thinkers propose that traces of these other realities could still be detectable within our cosmos. For instance, as our universe expanded, its fundamental characteristics may have been shaped by collisions with other cosmic bubbles, providing a potential avenue for scientists to hunt for indirect evidence of the multiverse. One of the most fascinating concepts to arise from this discussion is the idea that some of these alternate universes could be governed by laws of physics so alien that life as we understand it would be impossible. Can you picture a reality where oxygen isn't essential for existence, or where the entire chemical basis for life is fundamentally different? The very thought of what might live under such extreme conditions is staggering, and it brings us to the profound philosophical questions raised by the multiverse. If there are countless universes, each representing a different possible outcome, what does that imply about the choices we make and the reality we experience? The concept that every decision you make might spawn an entirely new timeline forces us to question the nature of free will. Are we genuinely making choices? Or are we simply traversing a predetermined course that already exists within one of the infinite universes? As Michio Kaku delves into these possibilities, he also challenges us to consider our purpose. In a vast multiverse teeming with infinite variations, what is our significance? Does our existence have a higher purpose? Or are we merely one of an endless number of possibilities in an ocean of realities? This is where scientific inquiry and philosophical reflection truly converge. The quest for answers about the multiverse compels us to contemplate our own role in the cosmos and redefine our understanding of ourselves in the grand scheme of things. Our curiosity about the multiverse is more than a simple intellectual game. It represents a deep dive into the very fabric of existence. Ultimately, the concept of a multiverse challenges us to broaden our horizons and embrace all that we have yet to comprehend. We must, as Kaku does, keep our sense of wonder and our drive to explore alive, for the universe may be far more immense and intricate than we have ever dared to imagine. Every theory and every question brings us another step closer to unlocking the universe's secrets. This journey into the multiverse is just one of many paths we can take toward understanding the origins of our own cosmos, and perhaps the origins of all possible universes. How many times have you stopped to consider the nature of time? It appears to be a straightforward measurement, but it remains one of the most profound mysteries in the universe. In cosmological theory, time is seen as a linear progression from past to future. But what if I were to tell you that time itself was born in the Big Bang? This staggering idea completely upends our conventional grasp of chronology. Time, as we experience it, simply did not exist prior to the Big Bang. Before that singular event, the entire universe was compressed into a point of infinite energy, a state in which the very notion of time was meaningless. In this framework, the clock of the cosmos began ticking only at the moment the universe initiated its expansion. To put it simply, the Big Bang was the instant our universe's countdown started. But what does it mean for you and me if time truly began with the Big Bang? The implications for our everyday lives can be quite unsettling, as they force us to completely reevaluate our relationship with time. It is not merely a resource for scheduling our days or recalling memories. It is a fundamental dimension of our reality. Without the flow of time, there would be no change, no evolution, and, consequently, no life. Is it possible for something to exist outside of time? Some theories, such as string theory, suggest the answer is yes. By exploring additional dimensions, this theory posits that time might be just one of many components that construct our reality, opening the door to the possibility of other existences where time flows differently, or not at all. While trying to imagine a universe without time is mind-bending, it's a critical thought experiment for understanding how our own reality came into being. In this light, Kaku puts forward the idea that time is an illusion, a projection of the universe's inherent complexity. You can think of it like a movie, where a sequence of static frames creates the perception of a moving story. Our perception of time might just be a series of distinct moments that our consciousness strings together. This leads to a fascinating question. Could anything have come before the Big Bang? If time itself didn't exist prior to that moment, then the very word before becomes meaningless. The intimate relationship between time and the universe also urges us to reflect on the concept of destiny. If time moves forward in a straight line, does that imply that our entire lives are predetermined? Kaku invites us to consider that even though time has a single direction, the universe is so complex that it may allow for numerous possibilities to unfold. Every decision you make could be a thread in an infinite tapestry of realities that exist simultaneously. The paradox of time is also apparent in our understanding of cause and effect. If time is a consequence of the Big Bang, how does that change our grasp of how events are linked? Causality is a fundamental principle of science, but if time itself is flexible, our ideas about how one event leads to another might need to be more adaptable than we previously thought. In the realm of modern physics, time has become a hotly debated topic, with some theories suggesting it can behave in truly astonishing ways. Consider that in certain fields, like quantum mechanics, time isn't necessarily a constant flow, but may be a variable that can be influenced. This realization presents countless possibilities that fundamentally challenge our most established perceptions. The very notion that our comprehension of time is subject to change is, frankly, astounding, and it's a testament to the ongoing evolution of science. Contemporary research, such as the work being done by physicists like Kaku, strives to decode the puzzles of temporality and its deep relationship with the universe's essential architecture. It's conceivable that in the years to come, we'll gain a much clearer understanding of how time and space are woven together. We might learn that time is far more than a simple line connecting moments, but rather a dynamic fabric that interacts with matter and energy in ways we currently can't even fathom. This exploration into the nature of time inevitably brings you to profound questions about existence and significance. If time truly is an illusion, what are the implications for the way we live our lives? Kaku posits that our memories, experiences, and ambitions form a personal narrative that might just exist beyond the flow of time. A viewpoint that encourages you to search for purpose outside the typical boundaries of a linear life. Ultimately, this temporal paradox pushes you to contemplate the bond between humankind and the cosmos itself. Is it possible for you to feel a sense of home in a universe where the very foundation of time is so fleeting? The solution might be found in the way you decide to live, in the pursuit of meaning within this immense and wondrous expanse. The Big Bang wasn't just a cataclysmic explosion that produced everything you see around you. It was also the very dawn of time. You have to ask how an event could generate not only all matter and energy, but also the abstract framework of time itself. To begin to grasp this, you must first examine how time is understood on a cosmic scale. In your day-to-day life, you experience time as a straight line moving in one direction. You exist in a series of moments, with a past that is fixed, a present that is ever fleeting, and a future that holds infinite potential. Yet, when viewed against the vast backdrop of the universe, time assumes a completely different character and complexity. According to our best scientific models, prior to the Big Bang, absolutely nothing existed. No space, no matter, and most importantly, no time. You are left to grapple with an absolute void. What can this possibly mean for you? And how can your mind even begin to process a state where time itself was meaningless? The standard account suggests that time commenced its journey with the Big Bang. At that genesis, the entirety of space and matter was condensed into a point of infinite density and heat. As this singularity began its rapid expansion, the clock of the universe started to tick, and it's from that very instant that we measure its age. This, however, leads to a deeper, more mysterious question. Is time merely a way to measure events, or is it something far more fundamental? Imagine time as a great river, with each passing moment being a single drop of water. Before the universe began, there was no river, no water, and no current. The Big Bang set this river in motion, and with every drop that flows by, a new reality unfolds. In this way, every cosmic event, from the birth of a star to the collapse of a galaxy, contributes another drop to this river of time. But what if this isn't the only river? What if countless others exist, each flowing through a different universe in the multiverse? The concept that the Big Bang created time forces you to reevaluate the fundamental structure of reality. If time is a dimension not unlike space, then perhaps other temporal dimensions exist that you are not yet able to perceive. Consider the possibility that somewhere in the vast multiverse, time behaves differently. Perhaps it flows backward, or maybe moments are not sequential but exist in a perpetual cycle. As you travel further into cosmology, you encounter questions that frequently appear to defy simple logic. For instance, why does time seem to have such a clear, forward direction? The second law of thermodynamics offers a compelling explanation, stating that in any closed system, the level of disorder, also known as entropy, will always increase. This relentless march from order to chaos may be the very reason you perceive time as a one-way street. What does this imply for the universe as a whole? If you envision the cosmos as a book whose first page was written at the instant of the Big Bang, then every major event in its history as a subsequent chapter. But this leads you to wonder about the pages that remain blank. As the universe continues to expand, what kind of future is being written? And what does it hold in store for us? The answer promises to be as perplexing as it is fascinating. This line of thinking naturally leads you to question the ultimate destiny of time. As the cosmos expands, could there be a point where time itself ceases to exist, or is transformed into something else entirely. Some physicists theorize that time may actually slow down in an ever-expanding universe. Try to picture a distant future where time is but a faint whisper, a reality where events happen so infrequently that your very perception of its passage becomes warped. The paradox of time also makes you ponder its intricate connection to consciousness. If time is a framework that appeared with the Big Bang, how does that shape your perception of reality? Human consciousness, with its unique capacity for remembering the past and planning for the future, appears to share a special bond with time. It's even possible that our consciousness is a direct reflection of time, a mirror that captures the flow of the universe. As you explore these profound ideas, it becomes apparent that time is far from an abstract concept. It is an essential element of both the human and the cosmic experience. Time is the very thread that weaves your small part of existence into the vast and intricate tapestry of the cosmos. And it begs the question, can you ever truly comprehend the origin of time without first understanding your own place within it? The Big Bang, in giving birth to time, also presents you with an invitation to reflect on your purpose in the universe. You are a temporal being, living within a cosmos that is itself a creation of time. In such a vast and dynamic reality, what does that mean for your search for significance? The answer to that may be as varied and numerous as the stars scattered across the night sky. As you venture deeper into the mystery of time and its link to the universe's origin, you find yourself on a never-ending voyage of discovery. Every new theory and each fresh experiment brings you a step closer to understanding not just the cosmos, but also yourself. The narrative of time is inseparable from the narrative of the universe, and every breakthrough beckons you to keep exploring and to keep asking, what more will time reveal? The question of which physical laws enabled the universe's creation is a profound one that invites you to investigate the very bedrock of reality. From the instant of its initial expansion, a specific framework of principles has guided the cosmos's development, revealing that its origin was not an act of magic, but the result of physical laws that are as intricate as they are astonishing. The fundamental goal of physics is to decode these universal secrets and understand the crucial role they played in cosmic birth. Consider gravity, the same force that anchors you to the Earth. This fundamental interaction was also the cosmic architect responsible for assembling galaxies, stars, and planets from primordial matter. In a universe without gravity, the cosmos would have remained a disordered and featureless expanse, a chaotic soup of particles unable to coalesce into the magnificent structures we observe throughout space today. In addition to gravity, energy holds a central position in the story of cosmic creation. Albert Einstein's celebrated equation reveals the deep connection between mass and energy, implying that everything you perceive possesses an inherent energy. This primordial force was the engine for the universe's expansion following the Big Bang and the very substance from which matter precipitated, meaning that you are intricately woven into an immense energetic tapestry that spans the entirety of space. The concept of creation is also deeply tied to the laws of conservation, which dictate that matter and energy can only change form, never be created or annihilated. When applied to the Big Bang, this principle suggests the total sum of all matter and energy in existence today was present from the very beginning. This naturally leads to a question that pushes us to the edge of current knowledge, where science converges with philosophy. What was the state of this energy before cosmic expansion began? Another crucial element for comprehending the universe's origin is the principle of symmetry. You can see repeating patterns all around you in nature, from the spiral arms of a galaxy to the veins of a leaf. These are not random occurrences, but reflections of foundational rules governing the behavior of energy and matter. When these symmetries are disrupted under extreme circumstances, extraordinary new phenomena can arise, prompting us to wonder what realities we could unlock with a deeper grasp of these principles. An equally fascinating viewpoint on creation comes from string theory, which proposes that fundamental particles are not dimensionless points, but minuscule, oscillating filaments of energy. The specific frequency of these vibrations dictates the characteristics of every particle that constitutes our reality. If you imagine the universe originating from a single primordial vibration, then creation itself can be pictured as a grand cosmic symphony. An astonishing thought that the universe is made of music that continues to echo through time. The nature of time itself presents another compelling facet of creation. It's possible that time as you experience it did not exist before the Big Bang, but was born in that very moment. This notion directly confronts our intuitive perception of time as an endless, straight line. Such a perspective forces you to reconsider your relationship with time, questioning how this fundamental dimension shapes your past, present, and future, and ultimately, your very existence. Any exploration into the physics of creation must also confront the enigma of dark matter and dark energy, components of the universe that remain largely beyond our comprehension. These strange substances constitute the vast majority of the cosmos's mass energy and are the driving force behind its accelerating expansion. If these mysterious forces were integral to the universe's birth, one can only imagine the new revelations that await as our study of them deepens. To find answers to these profound questions, the scientific community relentlessly tests these theories through a variety of experiments. From the immense power of particle colliders to telescopes peering back toward the dawn of time, every new piece of data moves us closer to a full understanding of creation's governing laws. The great challenge, of course, is how to persist in deciphering these secrets within a cosmos of such unimaginable scale and complexity. Contemplating the physical laws that permitted the universe's formation naturally leads you to reflect on your own place within it. If your existence is a direct consequence of these principles, what is your significance in the grand cosmic narrative? You are, in essence, the universe observing itself, a conscious manifestation of the very same forces that forged stars and shaped entire galaxies over billions of years. It is easy to imagine creation as a singular event lost in the distant past, but the truth is that it is a process that continues unfolding. Each moment you live is a fresh expression of the universe's fundamental laws in action. This intimate, unbreakable link between your daily life and the majesty of the cosmos invites you to view the universe not merely as an empty stage, but as a dynamic environment in which you play an active part. In the search for cosmic origins, the paths of science and philosophy frequently merge. The deeper our scientific inquiry into the laws of creation goes, the more we are confronted with existential questions concerning our role and purpose. This raises a compelling possibility. If every part of the cosmos is interconnected, perhaps there is a more profound significance to your life within this immense universe. Ultimately, studying the physics of creation reveals a fundamental truth about science. Every answer we find only uncovers a new layer of questions. This perpetual cycle ensures that the quest for knowledge is endless, with each discovery inspiring us to explore further and to marvel at the complexity of it all. The universe is an arena of profound mysteries, and your curiosity is the engine that propels you forward, allowing you to participate in this grand adventure where new wonders constantly await on the horizon of understanding. This journey of inquiry naturally leads to one of the most captivating questions of all. Does life exist elsewhere in the cosmos, or perhaps even within parallel universes? The very notion that humanity may not be alone is a concept that fascinates scientists, philosophers, and dreamers in equal measure, presenting a prospect that is as profoundly challenging as it is inspiring. The eminent theoretical physicist Michio Kaku encourages us to investigate a truly captivating possibility. According to his vision of the multiverse, life might be substantially more prevalent than we currently imagine. Picture a limitless ocean of parallel universes, each governed by its own unique set of principles and circumstances, where in some, stars have a different glow, and in others, the very laws of physics are completely alien to our own. What are the implications of this for life? In a reality so immensely varied and unpredictable, the presence of living organisms in other cosmic corners begins to feel not merely possible, but statistically probable. The quest to find life in these other universes forces us to ask profound questions about the nature of existence itself, compelling us to wonder if life is just a complex arrangement of atoms and molecules, or something far more significant. Science makes every effort to define life, yet much of it remains a mystery to us. Within a multiverse where conditions can differ so radically, life could emerge in forms that are currently beyond our ability to conceive. This framework suggests that living beings could manifest in ways that completely upend our conventional biological understanding, challenging everything we thought we knew. Consider the analogy of watching a collection of different films, where each one possesses a distinct plot, cast of characters, and setting. In much the same way, every universe could represent its own cinematic story, complete with unique forms of life that have adapted to their specific realities. The existence of multiple universes also introduces the possibility that in some of them, life has flourished under conditions that we would find unimaginably extreme. What if you could visit a world where the essential solvent for life is not water, but an entirely different liquid? Or a reality where life is built upon a silicon-based chemistry instead of carbon? The potential variations are truly infinite. As you ponder these concepts, it is only natural to ask whether we might ever discover proof of life in other universes. And this is where the field of theoretical physics becomes essential. What if you could visit a world where the essential solvent for life is not water, but an entirely different liquid? Or a reality where life is built upon a silicon-based chemistry instead of carbon? The potential variations are truly infinite. As you ponder these concepts, it is only natural to ask whether we might ever discover proof of life in other universes. And this is where the field of theoretical physics becomes essential. Even though we lack the ability to directly observe other universes, scientists are hard at work creating theoretical models that could allow us to infer their existence. Michio Kaku, for instance, has pointed out how disciplines like quantum physics and string theory may offer valuable insights into the fundamental nature of the multiverse. This multiverse concept also makes you think about the nature of fate and destiny. If there is an infinite number of universes, does that suggest that our choices could have played out differently in another reality? Each decision you make could theoretically branch off into a new universe with a completely different outcome, turning life itself into a kind of grand cosmic experiment. However, this inquiry extends beyond just the existence of life elsewhere. It forces you to confront questions about our own existence. If life is indeed abundant throughout the multiverse, what does that say about our own significance? You have to ask whether we are a product of mere chance, or if there is some greater purpose embedded in the cosmos, prompting a deeper reflection on our connection to everything. As our scientific capabilities advance, the search for life in distant parts of our own cosmos is becoming more and more practical. with missions to Mars and the study of exoplanets representing just the initial stages. The challenge of finding life in other universes, however, is a far more complex undertaking. When dealing with realities we can neither see nor visit, it is difficult to imagine how we could even begin to comprehend what exists there. Scientists are continually speculating on the precise conditions that would allow life to arise, and the growing field of astrobiology is dedicated to this search beyond our planet. This exciting journey has researchers looking everywhere, from the subterranean oceans of Jupiter's moon Europa to distant exoplanets within the habitable zones of other stars. Yet, the question of what lies in those universes completely beyond our reach remains. The idea that life exists in other universes also encourages you to reflect on the diversity of your own experience. If there is a reality where your choices were different, what would your life be like in that alternate world? The notion that you might have followed other paths in parallel realities inspires a deeper appreciation for the weight of the decisions you make in this one. Ultimately, the concept of life in other universes is more than just a scientific problem. It represents a deep exploration of our own place within the cosmos. It's a reminder that while you may sometimes feel isolated, we exist within a vast and mysterious reality. As we continue our search for answers, we may one day learn that we are not nearly as alone as we believe. The phenomenon of human consciousness has been an enduring source of fascination throughout all of history. Thinkers from ancient Greek philosophers to contemporary scientists have been captivated by the question of what consciousness is and how it relates to the universe. Is it simply a side effect of our brain's complex activity? Or is there a more fundamental connection between our minds and the cosmos? Michio Kaku, as a celebrated theoretical physicist and science popularizer, invites us to investigate this compelling link between consciousness and the universe. When you think about this connection, it is crucial to remember that we are all part of something much larger than ourselves. Each of us is made of atoms that were once forged inside stars. So in a very real sense, looking up at the night sky is like seeing our own distant origins. But what could this cosmic heritage mean for how we understand consciousness? And could it imply a connection that operates beyond the scope of conventional physics? The idea that consciousness might be a fundamental property of the universe is a concept Kaku has examined. Imagine if consciousness were not just a biological outcome, but a universal phenomenon that can manifest in countless forms across the cosmos. Analogous to how matter exists in different states, perhaps there are also different states of consciousness. This line of questioning urges you to reconsider what it means to be conscious and how that awareness is tied to the very fabric of the universe. This concept of consciousness existing apart from physical matter is a topic debated for centuries, with some philosophical traditions even proposing that it is a primary force, much like gravity or electromagnetism. Consider the possibility that consciousness is not a byproduct of life, but a fundamental property that has existed since the dawn of time. This viewpoint forces us to ask what consequences such a reality would hold for our entire conception of life and being. Kaku proposes that consciousness might even be an active participant in shaping reality, suggesting that your very perceptions and thoughts could actively mold the world you experience. Is it conceivable that the universe itself acts as a reflection of our shared awareness? This notion finds a compelling echo in the principles of quantum physics, where the act of observation seems to directly affect the conduct of particles. This parallel naturally leads to a profound question. What if your own consciousness holds the very key to deciphering the universe's most guarded secrets? A number of scientists are now venturing into this frontier, investigating the link between consciousness and quantum events to grasp how the mind could possibly engage with the physical world. This entire line of inquiry presents a truly captivating proposition. If your awareness can indeed impact the cosmos, does this mean that you are, in some fundamental manner, authoring your own existence? The very concept of a universe engaged in a continuous exchange with our consciousness fundamentally subverts our conventional understanding of causality. You could also view consciousness as the unifying thread that links every living entity together. If we accept that we are all woven into the same cosmic tapestry, it becomes crucial to ask how our collective awareness impacts the health of the entire universe. Is it possible that your thoughts and actions ripple outward, affecting not just your own life, but the entirety of your surroundings? Picture a cosmos in which consciousness isn't an isolated accident, but an integral component of reality itself. The capacity of humans and other life forms to perceive and comprehend their surroundings might imply that awareness serves a greater function. Perhaps the process of evolution is itself steering consciousness on a trajectory toward a more profound comprehension of its own nature and the universe it inhabits. Investigating the link between consciousness and the cosmos compels us to confront more profound questions about meaning and existence. If your own awareness is a direct expression of the universe, it follows that you have a significant part to play in its grand, unfolding narrative. This leads to the striking idea that conscious beings might be the very mechanism through which the universe becomes aware of itself, implying that each of your thoughts and feelings reverberates throughout the cosmic fabric. Kaku further contemplates the potential ties between consciousness and spiritual concepts. Within numerous spiritual frameworks, awareness is regarded as a sacred bridge, linking humanity to the divine. When you adopt this viewpoint, science and spirituality no longer seem opposed, but rather appear as complementary approaches, each endeavoring to solve the most fundamental questions of existence. This intimate relationship between consciousness and the cosmos prompts a reevaluation of your own identity and what it signifies to be human. If you are truly a part of the universe, are you fated to move beyond your physical constraints into new realms of being? The notion of an evolving, expanding consciousness hints at a thrilling future in which humankind could forge entirely new methods of engaging with the cosmos. Ultimately, delving into consciousness within a cosmic framework is less a purely scientific endeavor and more of a profound philosophical voyage. It offers you a chance to contemplate your position in the universe, potentially discovering a deeper sense of purpose and connection. Perhaps your awareness acts as a guiding light in the vastness of space, illuminating the path to a greater comprehension of your own existence. This profound mystery beckons you to keep searching, fueled by the spark of human curiosity, quite possibly the most precious gift the universe has bestowed upon us. On this path of discovery, each question you pose may edge you closer to the truth of who you are and the reason for your being here. Could it be that every law of physics is intricately linked, forming the individual pieces of a single cosmic puzzle? This quest for a unified theory has long fascinated both scientists and philosophers, reflecting our ancient drive to comprehend the regulations that manage the universe. The importance of unifying these laws might seem intricate, yet it is absolutely essential for decoding the deepest secrets of the cosmos. To understand this, think about playing a video game where each stage has unique rules that are nevertheless all part of a single, overarching system. In physics today, we possess distinct sets of rules for different domains. Einstein's theory of relativity dictates the dynamics of massive objects, while quantum mechanics explains the strange realm of subatomic particles. The challenge is that we still haven't figured out how to combine these fragments into one coherent theory. You can think of relativity and quantum mechanics as two separate languages attempting to describe the same universe, yet they are mutually unintelligible. This creates paradoxes such as why an immense object like a black hole should operate under principles so different from those governing a minuscule particle of light. It is precisely this kind of question that motivates researchers such as Michio Kaku to pursue a unified theory, which he believes is vital to grasping the fundamental nature of reality. So, what might be the solution to achieving this grand unification? String theory stands out as one of the most compelling candidates. If you've ever experimented with strings to form different shapes, you can grasp the basic concept. It posits that the universe's fundamental components are not points but tiny, oscillating strings. The specific frequency of a string's vibration dictates a particle's characteristics, a concept that could provide a framework for uniting all of nature's forces. You might wonder how this connects back to the universe's origin. If every force is fundamentally linked, it implies that the Big Bang not only brought the universe into being, but also set the very laws that have governed it ever since. Consequently, the pursuit of a unified theory is an effort to comprehend not just the cosmos as it is now, but also its most distant past. What exactly unfolded in the first moments that gave rise to our universe? The solution to this puzzle might be found where the theories of relativity and quantum mechanics converge. This idea of unification also brings up profound questions concerning the ultimate destiny of the cosmos. If we can figure out how to merge the fundamental forces, we might be able to foresee the universe's future, determining if we are headed for a gradual heat death or caught in an endless cycle of rebirth and destruction. Every new insight gained in this pursuit moves us closer to solving the enigma of time itself. To illustrate, think about a symphony conductor. While every musician has their own part and instrument, it is the conductor who unifies them into a harmonious whole. In the world of physics, a unified theory would serve as that conductor. Should we succeed in discovering it, we could finally grasp how all the universal forces interplay, and how that interaction has sculpted the reality you and I experience. The challenge, however, is immense, and scientists are relentlessly hunting for experimental proof that can validate these theoretical frameworks. From the operations at the Large Hadron Collider to observations made through powerful telescopes, each piece of new data could hold a clue to unifying the laws of physics. One must wonder what breakthroughs on the horizon are poised to completely reshape our conception of the universe. Throughout our history, countless scientists have committed their lives to achieving this singular objective. Figures from Einstein to Kaku have all shared the dream of witnessing the moment a unified theory is finally unveiled. The passion driving this search is still very much alive, and every new accomplishment edges us nearer to the ultimate answer. Yet the question remains, is it even conceivable to encapsulate all of existence within a single, elegant equation? This quest for unification carries with it deep philosophical weight. If it turns out that all forces are fundamentally intertwined, what would that reveal about our perception of reality? Could it mean that everything is connected in ways we have yet to even imagine? These are the kinds of questions that not only push scientists to their limits, but also call upon anyone who dares to ponder the cosmos to join in the reflection. As we delve deeper into these ideas, science transforms into a thrilling expedition into the great unknown. It is human curiosity that compels us to find answers, and each discovery has the potential to unlock new realms of what is still concealed from us. Merging the laws of physics may represent the next monumental leap in our comprehension of the universe, uniting not just the forces of nature but also our own inquiries about where we fit within it all. This is a journey fraught with uncertainty, but every attempt to find a solution is a significant stride toward greater knowledge. Even though the outcome of the search for unification is not guaranteed, our innate curiosity and the powerful drive to understand propel us ever forward. The Chronicle of Science is, at its heart, a story of discovery, and the pursuit of a unified theory stands as one of the most captivating chapters we are currently writing. What if I were to tell you that the solutions to some of the most profound mysteries about the universe's origins could be hidden within experiments that haven't even been designed yet? In the effort to understand how everything began, scientists have devised brilliant methods to test our models of the Big Bang and cosmic expansion. You can think of each experiment as a unique portal, enabling us to gaze back in time to that initial primordial moment. Among the most fascinating of these experiments is the use of particle colliders, with the Large Hadron Collider being a prime example. You should picture these colliders as immense laboratories where we can simulate the extreme conditions of the infant universe. Within this environment, minuscule particles are smashed together at astonishing velocities, generating a chaotic state that might just mirror the energy and density present right after the Big Bang. Is it possible that by witnessing these collisions, we are actually seeing the building blocks of creation? This naturally leads to the question of what we can actually glean from these high-energy impacts. By carefully analyzing the particles that fly out from these explosions, scientists can uncover hints about dark matter and dark energy, the enigmatic substances that constitute the vast majority of the universe. The process is akin to locating the final missing pieces of a grand cosmic puzzle, where each new piece clarifies our understanding of the complete picture. In addition to the work done in colliders, we have telescopes that probe the deepest reaches of space. Have you ever considered the secrets that might be locked away in faraway galaxies? By employing instruments like the Hubble Space Telescope, scientists are able to collect data that narrates the story of how the very first stars and galaxies came into being. Observing light that has journeyed for billions of years lets us see the universe as it was in its earliest stages, as if we are reading a history of the cosmos's infancy. At the same time, the study of gravitational waves is another critical frontier. These disturbances in the fabric of space-time were first predicted by Einstein, and their eventual detection has unlocked entirely new avenues in cosmology. What can these ripples tell us about cataclysmic occurrences like the merger of black holes? Every time we detect one of these waves, it provides a new lens through which to view the universe, much like tuning a radio to a broadcast carrying tales of its origin. Computer simulations are also essential to our search for answers. Researchers construct digital models to simulate how the universe might act under various sets of rules. What if we were to tweak the laws of physics within these simulations? Through this virtual experimentation, we can explore different variables that could have shaped the universe's development, allowing us to consider alternate scenarios that compel us to think beyond what we currently know. Every one of these experimental approaches shares a common objective: to either prove or disprove our current theories. But what is the next step if a theory fails to hold up under scrutiny? The entire field of science progresses through skepticism and continuous revision. Each time an experiment produces an unexpected outcome, it triggers a cascade of new questions. This is precisely how knowledge is forged, through relentless curiosity and persistent inquiry. The truly captivating thing about these scientific endeavors is that their purpose is not only to find answers, but also to generate entirely new puzzles. They are designed to push the boundaries of our knowledge, ensuring that the quest for understanding is a self-perpetuating cycle of discovery and wonder. Modern cosmology has completely reshaped the way you and I perceive the universe, revealing truths that fundamentally challenge our sense of reality. You might wonder how a cosmos this vast and intricate could emerge from such a precise origin. The answer lies within the decades-long evolution of cosmological thought, where the Big Bang theory, while a monumental achievement, represents only the first chapter of a much deeper and more complex story. In this journey of discovery, telescopes have been our essential guides. But I want you to consider that they aren't just instruments for looking into space. They are also machines for looking back through time. When you observe a faraway star, the light you see began its journey millions or even billions of years ago. This incredible effect provides a direct window into the universe's infancy, allowing us to witness its evolution from the earliest moments. Yet, contemporary cosmology ventures far beyond the Big Bang, introducing you to concepts like dark matter and dark energy that sound as if they were pulled from science fiction. It's a baffling idea that the majority of the cosmos is composed of substances we can neither see nor directly interact with. This may seem perplexing, but this unseen universe is absolutely essential for explaining everything from the motion of galaxies to the accelerating expansion of the cosmos itself. So what does it truly mean when we say the universe is expanding? I find it helpful to imagine a balloon with dots on its surface. As you inflate it, every dot moves away from every other, which perfectly illustrates how galaxies are receding from one another. This expansion naturally leads you to wonder what might lie beyond our observable horizon and introduces the theory of cosmic inflation. The idea that for an infinitesimal moment after the Big Bang, the universe swelled at an unbelievable rate, setting the stage for all the structures you see today. Another profound concept for you to consider is the relationship between symmetry and the universe's origin. In the world of physics, symmetry is an incredibly powerful tool that helps scientists formulate the laws of nature. As the physicist Michio Kaku suggests, the elegance and harmony you find within these physical laws might be fundamentally woven into the very fabric of creation. This deep connection between symmetry and the cosmos poses compelling questions about the ultimate nature of reality. To push the boundaries even further, you can look to string theory, one of the most captivating ideas in modern physics. It asks you to imagine that the fundamental building blocks of reality are not particles, but tiny vibrating strands of energy. The specific way these strings resonate could be the key to unifying all the forces of nature, potentially holding the solution to the mystery of how the universe began. When you then consider the possibility of a multiverse, the conceptual landscape expands exponentially, forcing you to reevaluate your understanding of life and existence. Could our universe be just one iteration in a vast collection of cosmic experiments? This very question fuels intense scientific and philosophical debates that continuously challenge our most basic notions of what is real. The deeper we probe, the more we confront the paradox of time itself. If the Big Bang was the genesis of time, then you have to ask what, if anything, existed before it. These reflections compel us to question whether time is an objective reality or simply a construct of our perception, forcing us to grapple with our own existence on this grand cosmic stage. The dynamic interplay between theory and practice is absolutely central to this entire endeavor. Every experiment is far more than a simple test of an idea. It's an ongoing dialogue between our scientific models and the universe itself. This monumental quest also depends heavily on international collaboration, creating a synergy that allows us to pool knowledge and resources, dramatically accelerating the pace of discovery. Ultimately, the nature of scientific progress is such that every new answer reveals an even greater expanse of what we don't know. It's an endless cycle of discovery and uncertainty. Each experiment is an attempt not just to understand our past, but also to prepare for the future, arming us with the knowledge to answer the deepest questions about our place in it all. So when you gaze at the starry sky, remember that every star is a reminder of the story we are trying to unravel, bringing us closer not only to the universe's secrets, but perhaps to understanding who we truly are. From the Large Hadron Collider to observatories detecting gravitational waves, every new instrument we build brings us a step closer to understanding the universe's fundamental truths. As our technology improves, so does our comprehension, and each new insight invariably gives rise to even more profound questions. Modern cosmology, in all its complexity and splendor, reveals that the cosmos is a realm filled with endless surprises, where each discovery not only offers a new vantage point on reality, but also invites you to reconsider your own place within it. This quest for knowledge is an unending odyssey, and as Michio Kaku rightly observes, our exploration of the universe is an adventure that has only just begun. The universe's origin poses questions that have captivated humanity since the dawn of thought, prompting us to ask what lies beyond the scope of our existence and what the Big Bang truly signifies for our cosmic awareness. These inquiries not only fuel our drive to explore physics, but also open up a vast arena for philosophical contemplation, revealing science and philosophy as two facets of the same pursuit of understanding. How does grasping the universe's beginnings shape your identity as a member of the human species? When you gaze into the night sky, do you feel like a detached spectator, or do you sense a deeper, more intrinsic connection? The notion that everything you know originated from a single cosmic explosion more than 13.8 billion years ago prompts a deep reflection on your position in the immense fabric of space-time. If the universe possesses such staggering age and scale, you might wonder what implications this has for the details of your everyday life. Each of us is the culmination of an immense chain of events that traces back to that one primordial moment. The very idea of time is redefined when you delve into the universe's origins. Is time a straight, unwavering line moving forward, or is it more like a complex cycle where all things are intertwined? Kaku posits that the Big Bang did not just create the cosmos, but also established the flow of time as you experience it, which raises a perplexing question. If time itself started then, what could have possibly existed before the Big Bang? Some scientific theories propose that time might be an emergent phenomenon, a byproduct of interactions on a cosmic scale, a concept that challenges you to rethink the nature of existence itself. Philosophy also pushes you to consider the question of purpose. If the universe seemingly sprang from nothing, is there any inherent meaning to its existence? Or are you here purely by chance? These ultimate questions about meaning and purpose stem from the very same curiosity that animates all scientific inquiry. And Kaku rightly points out that science and spirituality can offer complementary perspectives on the human experience. When you consider the possibility of a multiverse, philosophy ventures into even more fascinating domains. If countless other universes exist, each with its own distinct reality, what does that imply for your concept of free will? Are your decisions truly your own, or is your life just one expression within an infinite set of possibilities? This idea can be disorienting, yet it is also profoundly liberating, inviting you to view your life as part of a vast network of realities, where every choice could potentially unlock a new path. The study of dark matter and dark energy also prompts you to look deeper into your beliefs about the cosmos. If these unseen forces make up the majority of the universe, what does that reveal about your current understanding of reality? Science demonstrates that there is vastly more to existence than what you can perceive through your senses alone. The effort to understand this invisible realm forces you to accept the limitations of your perception and concede that reality is likely far more intricate than you can ever imagine. In this context, how do science and ethics intersect? As your knowledge of the universe and its origins expands, you inevitably confront ethical quandaries. The power to manipulate nature and use technology to explore the cosmos raises serious questions about your responsibilities. The decisions you make today could very well dictate how humanity interacts with the universe in the generations to come. This line of thought leads to the connection between consciousness and the cosmos, another subject deserving of deep exploration. Is consciousness simply an evolutionary byproduct? Or is it something far more fundamental? Some philosophers theorize that consciousness is a reflection of the universe itself, a mechanism through which the cosmos can come to know itself. This idea suggests that, as a conscious being, you may have an active role to play in the cosmic fabric, and perhaps your innate thirst for answers is an integral part of the universe's ongoing creative process. The dialogue between science and spirituality also encourages a contemplation of the universe's profound beauty. The elegant nature of physical laws and the magnificent wonders of the cosmos are not just subjects for dispassionate study. They inspire a deep sense of awe and reverence. While science can provide explanations, the direct experience of cosmic beauty can resonate with you on a much deeper level. It may be that the pursuit of knowledge and the appreciation of beauty are two distinct paths that ultimately lead to the same truth. As you advance on this journey of discovery, it is essential to remember that questions are often just as valuable as answers. It is your curiosity that propels you to continue probing the mysteries of the universe. Michio Kaku reminds us that in confronting the unknown, you also challenge your own preconceived notions and expand the boundaries of your consciousness. Every solution you uncover only reveals a new set of questions, and it is within this dynamic space of inquiry that the true essence of humanity resides. Ultimately, exploring the origin of the universe is an invitation to become part of something far greater than yourself. It's a reminder that you are a fragment of an immense, interconnected whole, linked across the vastness of time and space. In this quest to comprehend your place in the cosmos, Kaku and other scientists demonstrate that science is not merely a collection of theories and formulas. It is a shared journey toward understanding, a path you can walk with others, where each of you has a unique role in the grand story of the universe. How can spirituality find its footing in a cosmos that appears to operate under unyielding physical principles? In exploring the link between science and spirituality, Michio Kaku prompts you to think about how these two domains can not only coexist, but also mutually enrich one another. While science, grounded in observation and experimentation, endeavors to decode the universe's secrets, spirituality offers you a profound sense of meaning and connection within its immense expanse. This raises a fascinating inquiry. Can the scientific method provide solutions to matters traditionally reserved for the spiritual? Kaku proposes that science can frequently illuminate facets of our existence once thought to be beyond our grasp. For instance, grasping the mechanics of star and galaxy formation allows you to appreciate the cosmic spectacle in a manner that deeply resonates with your inner self, demonstrating that the universe's appeal is rooted as much in its capacity for inspiring wonder as in its mathematical elegance. The notion of a purposeful universe has been a subject of debate for millennia, with some asserting that the sheer complexity of life points to a deliberate design. However, Kaku reminds you that although science is an incredibly powerful tool for explaining how the universe works, it doesn't necessarily address the ultimate question of why. Consequently, your own search for meaning remains a deeply personal and subjective expedition. Scientific frameworks explaining cosmic origins, such as the Big Bang Theory, compel you to contemplate your own existence within this vast and unpredictable reality. To understand your place in this immensity, Kaku suggests that learning about your cosmic environment provides a type of knowledge that transcends mere facts and figures, helping to define humanity's ongoing narrative in an ever-expanding universe. Furthermore, the quest for answers about the cosmos can itself be a source of comfort when you are confronted with life's great uncertainties. Science can offer a structure that aligns with spiritual beliefs, and Kaku argues that instead of treating them as opposites, you can find a shared territory where they enhance each other. The scientific truth that you are composed of stardust, for example, beautifully reinforces the spiritual tenet of universal interconnectedness. A recurring question in cosmology is whether consciousness has a significant role to play, or if it is simply a byproduct of evolution. Kaku speculates that consciousness could be a fundamental property of the universe, akin to gravity or electromagnetism. This idea opens up a compelling new dialogue between science and spirituality about the true nature of reality, suggesting you are tied to the cosmos in ways not yet fully understood. The multiverse concept also stimulates deep reflection, challenging you to consider what infinite universes, each with distinct physical laws, would mean for your understanding of purpose and spirituality. While the thought of every possibility unfolding in a different dimension can feel overwhelming, it can also offer a liberating viewpoint where every life holds unique significance within a vast web of realities. While science has made remarkable headway in investigating these ideas, Kaku emphasizes that a great deal remains undiscovered, positioning the intersection of science and spirituality as a fertile ground for future contemplation. Integrating this knowledge into your daily life requires curiosity, an open mind, and a willingness to question your own beliefs, which become essential tools for deepening your understanding of yourself and the universe. By staying open to new possibilities, you can cultivate a more profound sense of purpose and belonging within the intricate tapestry of existence, where science provides a map and spirituality encourages you to explore your own emotional landscape. Kaku even puts forward the idea that your capacity for awe in the face of the universe is, at its core, a spiritual act. This innate human curiosity transforms the search for answers into a sacred pursuit. This connection to the unknown serves as a constant reminder that for every cosmic mystery you solve, countless others await. The relationship between science and spirituality is therefore not a strict opposition, but a complementary spectrum. Science hands you the tools to explore the cosmos, while spirituality provides the context for reflecting on your place within it. And Kaku invites you to undertake this journey with an inquisitive and receptive spirit. Ultimately, you are left with the most profound question of all. What does it truly mean to be human in such an enormous universe? While the convergence of science and spirituality offers potential answers, it also generates new questions. What truly matters is that the pursuit of knowledge, whether through a scientific or spiritual lens, remains an essential and rewarding part of your human experience. The universe's origin has fascinated humanity for countless generations, and as your comprehension deepens, so do your questions about what lies beyond our sight and why existence prevails over nothingness. Though philosophical in nature, these inquiries are the very engine of scientific progress, and figures like Michio Kaku serve as exceptional guides on this quest. Grasping that the universe has a beginning and a rich history fundamentally alters your perception, shifting it from a static, eternal space to a dynamic and constantly evolving stage. When you consider the Big Bang, you understand it wasn't just the origin of stars and planets. It was the very birth of time. This realization forces you to reevaluate your own existence and your position within this immense cosmos. It is our innate curiosity that then compels us to ask a fundamental question. Are we the only ones out here in this cosmic expanse? The prospect of alternate universes, each containing unique realities and perhaps different kinds of life, fundamentally questions your perception of what it means to be alive. You might even wonder if other versions of yourself exist within these parallel worlds. This concept of the multiverse is both fascinating and staggering, presenting a completely new framework for contemplating consciousness, life, and your ultimate fate. Another captivating area to delve into is the link between the universe and human consciousness, which leads you to question whether our presence is merely a cosmic accident, or if there's a more profound reason for it. Kaku proposes that consciousness could be a fundamental component of the universe's architecture, which would mean you aren't a simple spectator, but an integral player in this magnificent cosmic story. Such a viewpoint encourages you to imagine how your thoughts and deeds could be woven into the essence of reality itself. In physics, the pursuit of a unified theory echoes the notion that all things are interconnected. As researchers strive to merge disparate concepts like relativity and quantum mechanics, fresh inquiries into the universe's beginnings continually surface. This scientific endeavor mirrors your own innate human desire to find order and purpose within a cosmos that frequently appears random and chaotic. The philosophical consequences stemming from these scientific findings are truly immense, forcing you to reconsider your entire conception of reality, existence, and your place in the cosmos. If a universal connection does exist, you must ask what that implies for your personal relationships and the choices you make. Every new scientific breakthrough introduces another level of intricacy to your life, yet it simultaneously presents a chance to uncover a more profound sense of meaning. Within this framework, science and spirituality, which you might typically view as conflicting, can actually find common ground. As Kaku points out, gaining a scientific comprehension of the universe can lead you toward more spiritual inquiries about your purpose and existence. Far from dispelling your sense of wonder, science has the power to greatly enhance and deepen your overall experience of being alive. The entire saga of the cosmos, stretching from the Big Bang to the emergence of life, is a remarkable story that calls you to recognize your role in something far larger than yourself. Each star you see, and every atom composing your body, is the product of a cosmic journey that took billions of years to unfold. Feeling this profound connection to the universe can motivate you to protect our world and work towards a future where humanity flourishes in concert with the cosmos. In the end, what Michio Kaku urges you to do is to never stop exploring. Each question you pose and every solution you uncover moves you a little closer to solving the universe's great puzzles. Even if you never obtain all the answers, the pursuit itself holds immense value, because it is your curiosity and your thirst for knowledge that propel you onward. As you gaze toward the future, you can't help but speculate on how science will reshape your comprehension of both the cosmos and yourself. What groundbreaking new theories will arise, and which radical experiments will completely alter your worldview? You must remember that the cosmic tale is still being written, and you are an active character in this continuously unfolding drama. Every scientific step forward serves as a potent reminder that the universe is a realm brimming with mystery and awe. The elegance of the cosmos is found not just in its sheer scale, but also in your capacity to be amazed by it and to formulate questions. This quest for understanding is a perpetual voyage where you have a part to play. So as I conclude this section on cosmic origins, remember that the exploration of space is among the greatest journeys you can undertake. I urge you to keep questioning, keep searching, and most importantly, keep dreaming.